What is the difference between humidity and dew point, and why are this measurement very critical in pharma clean rooms and HVAC system? In this video, I'll explain humidity measurement in very simple way. Hello everyone, this is Raj from TechArt, your process automation strategist. In the previous module, we have learned about temperature measurement system including ITD sensors, thermocouples, transmitters, indicators and controllers. Now, we will move to another very important industrial parameter, and that is humidity measurement. Humidity plays a very critical role in many industries, especially in pharmaceutical manufacturing, HVAC system, food processing, clean rooms and dry rooms, also compressed air systems. So today, we will understand how humidity and dew points are measured in industrial environments. Now let's start with humidity first. Let us understand humidity with a very simple example. When you walk outside during the rainy season, sometimes the air feels very sticky and uncomfortable. That happens because there is too much moisture in the air. This moisture in air is called humidity. Humidity means the amount of water vapor present in the air. In industries where humidity must often be controlled very precisely because too much or too little humidity can affect your product quality as well. The most common humidity measurement is called relative humidity or RH. Relative humidity is expressed in percentage. Now let's take one example: 30% RH, 50% RH or 80% RH. If RH is 50%, it means the air contains half of the moisture it can hold at that temperature. Now, most industrial humidity systems measure relative humidity. Now let's understand with some examples. Pharmaceutical clean rooms. In pharma manufacturing areas, humidity must be controlled very carefully. If humidity is too high, tablets and powders may absorb moisture. This can affect medicine quality, and that is why pharma clean rooms maintain humidity typically between 40 to 60% RH. Now let's take another example. In HVAC systems, humidity control ensures comfort and air quality. Offices, hospitals and labs require proper humidity control. Too much humidity may cause mold growth, and too little humidity may cause dry air and static electricity. Some industries like battery manufacturing and electronics require extremely low humidity. These rooms are called dry rooms. In such rooms, humidity may be controlled below 1% RH. To measure humidity, we use humidity sensors. Most modern humidity sensors use capacitive sensing technology. These sensors detect changes in moisture content in air and convert it into the electrical signals. Now, humidity sensors are usually combined with temperature measurement as well. So many devices measure temperature and relative humidity together. Humidity sensors usually produce small electrical signal. These signals needs to be converted into a standard electrical signals, and that is why we use humidity transmitters. A humidity transmitter converts the sensor signal into output such as 4 to 20 mA, 0 to 10 volt and Modbus communication. These signals can then be converted to PLC system, controllers or SCADA systems. Now, humidity transmitter may be installed in different ways, like wall-mounted transmitter, duct-mounted transmitters, also probe-based transmitters, depending on your application. Now, let us talk about another important concept, and that is dew point. Dew point is the temperature at which moisture in air start to condense into water droplets. Let us understand this with a simple example. Imagine a cold water bottle placed on a table. After some time, you will see water droplets forming outside the bottle. That happens because the surrounding air has reached its dew point temperature. In industrial system, dew point measurement is very important when we deal with very dry air or compressed air system. Dew point is measured typically using dew point transmitter. These instruments measure the moisture containing very dry gases or air. Typical applications are compressed air systems, industrial dryers, gas pipeline, or air separation plants. Dew point is usually expressed in degrees Celsius. For example, minus 20 degrees Celsius dew point, minus 40 degrees Celsius dew point, or minus 60 degrees Celsius dew point. The lower the dew point, the drier the air. Now, let us understand the difference between relative humidity and dew point. Relative humidity depends on temperature. If temperature changes, relative humidity also changes. But dew point represents the actual moisture content in the air, independent of the temperature. So, RH is commonly used in room air monitoring, while dew point is used in dryer and compressed air system. So now, as an application engineer, understanding this difference is very important. Another very important aspect of humidity measurement is sensor placement. The sensor must be placed where it can measure representative air conditions. For example, in clean rooms, sensors should be placed in airflow areas not near the doors. While in HVAC ducts, sensor must be installed inside the air ducts. And in compressed air system, dew point sensor must be installed after dryers and filters. Incorrect sensors placement can lead to incorrect readings. So, different industries require different level of accuracy. For example, HVAC system may require plus or minus 3% RH accuracy, while pharmaceutical clean rooms may require plus or minus 1% of RH accuracy, while dry room environments may require very high precision dew point sensors. So, when selecting the humidity instruments, always consider accuracy, operating temperature, response time, and installation method. Now let's take a very real example. A customer says, I need humidity monitoring for pharmaceutical clean room plant. Now you should ask here, what is the RH range required? What accuracy is needed? Where will be the sensor installed? Wall mounted or duct mounted version you need? Based on this information, you can recommend a suitable humidity transmitter with display or analog output. This is how application-based instrument selection works. So in this module, we have learned about what is humidity, what relative humidity means, what is humidity sensor and humidity transmitters, dew point measurement and dew point transmitters. We also understood RH versus dew point sensor placement and accuracy requirements. So, humidity and dew point measurement are very important in industries like pharma, HVAC, compressed air system, and dry rooms. Understanding these measurements helps application engineer recommend the right instruments to the customer. So in the next module, we will learn about pressure measurement system which are widely used in pipelines, compressor, and hydraulic system. Thank you so much for watching. See you all in my next video.